Yeah. So what is this new package? It is for spatial predictive modeling. Actually, it's SPM. This package will try to introduce some new accurate hybrid method of geostatistical methods and machine learning methods. And we released this package last year and updated in March of this year. And then, so what are the spatial predictive methods? Based on the study in 2008, we had around 32 methods in there. Basically, the spatial predictive methods, they are using the existing point data to generate predictions for in spatial overgrids, generate continuous spatial data. Those highlighted things, they are commonly used or compared methods. That is IW and ordinary clicking. You will find why I highlighted them there. And from 2008 to 2014, we gradually introduced the random forest, support vector machine, general regression neural network, and generalized boost regression modeling methods into the spatial statistics and hybrid with the existing methods, and then we produced 8 hybrid methods in there. And during last many years, we compared those methods with a bunch of other methods, and to assess the performance of the predictive methods, there were many error measures proposed. You can say each of them has some kind of its own property. It's either unit dependent or variance dependent, and they will tell you the accuracy or not. And the list here, actually, we are going to include that into the package. Actually, has already been done. Here, I'm going to show some error mirrors in relation to the accuracy mirrors, and actually, this provides us the information to convert your existing error mirrors into the accuracy mirrors. And we also consider the cross-validation or validation method in the package. And you will see that this is the results based on 100 iterations of 10-fold cross-validation. You can see the accuracy varies between 32 to 42, right? And so if you just do one cross-validation method of the accuracy, you make it, say, 32 or 42. That's a huge difference. So that's why we need to to stabilize this. And actually, the method in the R package has been tested, applied to a lot of variables like seabed mud, the sand content, and gravel, seabed hardness, and the sponge species richness, and even to the terrestrial data, that is the forest fire danger index. This is the performance of those methods. Generally speaking, they increase the accuracy rate by 40 to 500%. And in the package, we have considered 10 methods in there. But for random forest, we have random forest and ranger. And we tried to include the fast version of GBM, that is XGBoost, but there's something, some technical issues with XGBoost, so we didn't include in this new version. Perhaps in the future, if the problem solves, and we will include it in the new pack in the further version. Actually, for each method, we have two functions. One is cross-validation function. One is the function to generate the predictions for you. And the cross-validation function basically covers the whole knot from the data split to model derivative to the model validation. And when you run that, for example, like a random forest, like IFOKCV, that is the hybrid method of random forest and auto-Kriging. If you run that, and then you get the accuracy of the method for your data. And then another function, this will give you the predictions, the spatial predictions. So basically, we'll try to simplify the whole process into two functions. And right, so now the functions in SPM. And if you type those two lines, and then you'll get something like this. And if we look slightly closer to that, you'll see that there are more functions in there. For example, like God, I cannot see from here. For example, like GBM, okay. No. Yeah. Yeah, right. For example, GBM OKCV and GBM OKPrint. So for that method, you only have two functions to run. Actually, we have over 20 functions in there. And then for the accuracy function, we have a pre-accuracy that includes a lot of error mirrors and accuracy mirrors. And we'll also have another function called a VECV and a further function to VECV that is convert your error mirrors to VECV. Why is that important? Because during past years, a lot of papers have been published just based on error mirrors. Basically, we have no idea how good they are. A summary study based on around 300 cases, that 9%, 8-9% of those with negative accuracy mirrors. That is, if they present their study in terms of accuracy, they will never get the thing published, because the model is worse than the absolute mean, or the global mean as the predictions for their data. Now, the applications. I'm going to to show two methods. This is IWCV, that is commonly used method, and you can say basically you have just one line, the height line. That is the thing you should use, and plug your data in. The first 1, 2 is that is the location information, and number 5, that is the target variable, and that's it. And if you run it, you get accuracy 23%. And as I showed before, that is just based on one iteration of cross-validation. To stabilize it, we need to repeat it, but here we only have to put 20 times. And you can see the average accuracy is 18%. And of course, you can plot the thing. The code provided there is you can produce the plot I provided you before, I showed you before. And then next is random forest OK CV. And again, 19 code, you can run random forest, the hybrid of random forest and auto Kriging. And again, the first two spatial data, the location data, and then the next, the 1, 2, 2, 6, 9, that is your predictors. And the last one, that is your target variable. And here we say pred-ACC, that is predicted accuracy, we use the VCV, okay? And you can say for the same data, we have 39% accuracy. That is increased from 18 to that. And so if we repeat that many times, you'll get average one 37%. That is pretty high according to the overall average accuracy studies published in environmental science, because the average accuracy is around 30%. So this is the marine data. You need to remember everything underwater is hard to sample. Thank you. Interesting. This is something recently happened on geostat mailing list. Some guys run their method using KED GOR and KED GStat, and then we say, right, I recommend them to use the SPM. Actually, I run the SPM based on exactly the same equation they used in there, and you can say how much the predicted error being reduced by these new methods. And this is for this in Australia. Now the audience from Australia. This is say to run SPM on the national computation infrastructure. Basically, say we can repeat what we just done on CI, and if you type VNet, I just heard some people love it. If you type VNet SPM, you'll get more examples, including the thing for making spatial predictions. I haven't shown you that here. Yeah. Basically, this the aim, as just mentioned, to introduce the new method for spatial predictive modeling. And it will try to simplify and streamline the modeling process and the application process, and to improve the efficiency and also the accuracy. Right. So as I stated in the vignette, a further method will be added to the package, and actually we'll welcome everyone here to make their contribution to this package by sending me your functions, and I can include in them. And all right, yes. And I need to thank a lot of people from my co-authors during the last 10 years and the R community to help me to get this done. Actually, this package summarized my work during the last 10 years. And also, I need to thank the, say, RStudio and the mailing list. They helped me to this stage. And that is a lot of things to support. I said in there. And then questions. What do you mean?
So you, like ordinary kriging, for example, yes. you can't have a formula where you have like covariates other than your spatial location distances between them.
Yeah.
But do you have functions in the package where you can use these methods?
I would say this. The question is, say, if you can include the, if my understanding is correct, to include the trend into your model. Basically, this is the hybrid methods, no matter it's random forest or support weighted machine or GBM, they all deal with that bit. So the hybrid method, the first part is still with the trend. I'll call that global trend or things like that. And the second part deal with the local variation. So that's why the hybrid method is more accurate than those compared methods like RGW body kriging. Yeah.
Okay,
yeah.
Thank
you. A lot of the error measures seem to be mainly concerned with point predictions. Do you also look at predictive uncertainty or predictive intervals?
Right. The question is that for this point, predictions, do you consider the uncertainty associated with them? My answer to that is yes and no. For the initial release of this package, we didn't include anything like that. For the second version, yes, we include the uncertainty for those kriging related methods. But again, as been pointed out by someone else long time ago, the uncertainty associated with kriging method, has nothing to do with the predictions. That only mirrors the change over the space of your samples. And so that is why we made this count of change. And a bit further to that is from our study, it shows that people, they are talking about the confidential, the confidence intervals, things like that. That is based on the fitted model, not predictive model. If you apply that to predictive models, you make a mistake. The reason is why I would suggest you guys read my recent paper published last year. That is included in this in this PowerPoint is for sponge species richness prediction. If you read that, you'll find out why.